See, we are going to study matrix. Okay. Before we study matrix, we should know how the matrix is being generated. You all know what is a matrix? It's a two-dimensional array. Two-dimensional what? Array is called as a matrix. Now we are going to learn how it is generated, how a pointer helps you to implement the matrix. Okay. So now let us see here right now. I have written here in this place is A. By writing A, what I've done, I created a memory. I allotted a memory. 4 bytes have been created. What is the name of the 4 bytes is A, and it is let's assume the address is 715. I'm going to say here in this place A is equal to 5. 5 is stored inside. If I say printf and I'm going to print the A, what I'm going to get, I'm going to get the value inside A. How much I get? What? 5. Next I say here in this place is A. I'm going to put a square bracket here. If I put a square bracket and I'm going to say here in this place is 5 or 3, let us say 3. What I have done, I created an array of size 3. These 3 bytes are stored in an adjacent memory. Let's say this is 215, this would be 21, because size of a pointer, size of an integer, 219, 223. What I'm going to store in this place is A is what? 215. I'm going to say A is equal to 5. Not possible. Why? Because A is no more an ordinary variable, it is a pointer variable. Print a percentage the A. What I'm going to get? I'm going to get the address 215. If I want to store a value, I can store here. This is we identified as A of 0. This is we identified as A of 1. This is we identified as A of 2. What is A of 0 is nothing but star of A plus 0. A of 0 implies star of what? A plus 0. A is how much it is what? 215. 215 plus 0 is 215, star is this, right? Therefore, we write here in this place is A of 0 is equal to, I put here 25. The 25 is stored here. If I want to put here what I can put, I can say here in this place A of 1 is equal to 30. 30 is stored here. Right? This garbage is there. If you want to print it, what I'm going to say? I'm going to say here printf percentage d A of 0. If I say A of 0, what is the output? I'm going to get what? 25. Here A is a pointer to an array. A is holding the first address of an array. It's a constant pointer. It is a constant what? Pointer, right? It's a constant pointer. Now look at this. I'm going to put here in this case A3. What it means, what is going to do? The system is first is going to make 3 into 4 is 12. 12 blocks is going to make. It's going to make 12 blocks of type integer. That means each block will occupy what? 4 bytes. 12 blocks. So 12 blocks are being made here. All the 12 blocks are stored in one line in an adjacent memory. What do I mean by this? If I say if the address of this is 115, this is 119, this is 123, this is 127, and this is 131, this is 135, 139, 143, and it goes like this. All the 12 blocks are stored in an adjacent memory. After creating the 12 blocks, after creating 3 into 4, 12 of type integers, the system is going to create an array of size 3. What it is going to store in the array? It is going to store the first address of every fourth block. That means here 115 is stored, here 131 is stored, and here 147 is stored. After doing this exercise, every what I said, it's going to create an array of size 3 and is going to put the first address of every fourth block. After creating this array, the system creates a pointer. Creates a double pointer. In that pointer, it is going to store the first address to one. Therefore, last time my A was a pointer to an ordinary variable. This time my A is a pointer to a pointer variable. Why? Because 215 is last time was storing a value. This time 215 is storing what? An address. Last time these blocks were storing values. This time these blocks are storing addresses. Therefore, this is a pointer. It's a single pointer array. And this is a double pointer, and it is a constant pointer, and also pointed to a constant also. That means this a using the, you can't change the value of a, and using the a also you can't change the value inside. You can't change the value what inside. That means this also is what constant. What about this? No, this is a variable. You can use any time. Therefore, now a became a double pointer. That means can I say a is equal to 5? No. What is the output of a? 215. But what is the difference between last time and this time 215? Last time it was an address of a ordinary variable, whereas this is an address of a pointer variable. What I will get a of 0? A of 0 is star of a plus 0. A is 215. 215 plus 0 is 215. Star is this. In this block, I can't store 25. Why? Because it's already storing an address and it's a constant also. You can't change constant pointer A of 1 is 30. Not possible. A of 0 will give me 115. Now look at this. What about if we say A of 1? I'm going to get what? 131. That means now when I say in a two-dimensional array, a single dimension will refer the first address. Will refer the first address. Okay. Sir, A of 0 is what is a value? No, is an address 115. If I put a star before it, it is going to give me a value inside. What is the value inside? A of 0 gave you 115. Star will give a value. Now we need to understand the pointer arithmetic and how we'll solve this. Okay. Now let's say in this places, I'm going to say here right now. See, this is what I'm going to use the same array. I'm going to put right now like this. So if you like my session, kindly share, subscribe, and like. 3, 4. By doing this, I got the structure. Correct. I'm going to initialize. I'm going to what? Initialize. Okay. How to initialize here in this places? If you want to initialize, you can initialize at the line of declaration. One. Now, in this place, see here, if you want to initialize for the first four elements, I'm going for the first four elements. I'm putting a brace. I put 1, 2, 3, 4. So 1 is here, 2 is here, 3 is here, 4 is here. Now see here, I'm going to put a next comma. I put 5, 6, 7. What is here? 5 here, 6 here, 7 here. What will be here? What? 0. Why? Because you put a column here. Now 8, 9, 10, 11. 8 here, 9 here, 10 here, 11 here. Correct. Now, sir, my next is here. I'm going to say here in this place A. What I'm going to get? A means I'll get what? 215. Agree? Right? A means 215. What about if I say A star A will give me what? Star A will give me what? Value at 215. How much what? 115. What about star A? A gives you 215. Star A gives you value at 215. Star A will give value at 115. How much I'll get? That means in a two-dimensional array, if you want to access an element, you need to use 2 pointers. If you want to access element, you need to use 2 what? Pointers you need to use. Okay. But you don't need to use explicitly, you can use implicitly. How? Okay. Now look at this. A gave you 115. 215, right? If I say here in this case, A plus 0 will give me what? If you add 1 with an integer pointer, it'll jump 4 bytes. It's a pointer to pointer, it'll jump what? 4 bytes. But you added 0, that means remains 215. Now, if I say here in this place, A plus 1, what will give me? A plus 1. A is 215. 215 plus 1 is how much? What? 209. Now, if I say here in this case, A plus 2 would give me 223. Correct. Now, look at this. If I say A gave you 215, A plus 0 also gave you 215. If I say star of A plus 0, how much will be? A plus 0 is 215, star is 115. This can be written by you as A of 0. Correct? We store an array. This will give you what? 115. Now, A of 0 is an address. A of 0 plus 2 would be what? 115 plus 2. If you are adding with 115, you are adding what? 2. 2 means you add 8 bytes. 115 plus 2 is what? 123. 123, if I say star of A of 0 plus 2 would give me what? 123 star. This is how much I'll get? 3. A of 0 is 115. 115 plus 2 is 123. Star is what? A of 0 plus 2. See, A plus 0 star is A of 0 you wrote. A of 0 plus 2 star is what? You can write A of 0, 2. A of 0, 2 will give me what? A of 0, 2 will give me what? Correct? This. So no sir, I want to access this. I want to access, let's say in this case, I want to access the 10. Okay, don't worry. If you want to access the 10, what I should do? First is I need to go to 147. Correct? Now, how to go to 147? I am going to say here in this place A of 2. How much I'll get? 147. Right? What is A of 2? Star of A plus 2. A of 2 plus what? Plus 2. How much? 147 plus 2 is how much it is what? 155. 155 star will give me what? 10, which can be written by you as A of 2. Done. Okay, sir. My next question comes to you. Can you please tell me? Can I say here in this case A of, I want to access right now, let's say 6. If you want to access 6, I have to go to 131. How to go to 131? A of 1 will give you 131. With the 131 and I add what? 1. How much will become? 135. 135 star would be what? 6. Which is you can write A of 1, 1. That means if you want to identify, this will be identified at the 0th row, first row and second row. See, I went to second row, second column. This is 0th column, first column, second column, and the third column. Got it? So that means if I want to access this 5, what I should do? I need right here in this case A of 1, 0. A of 1, 0, how will it be expanded? Star of A plus 1 plus 0. A is how much it is what? A is 215. 215 plus 1 is how much it is what? 219. 219 star is what? 131. 131 plus 0 is what? 131 star is what? That means your row index starts with 0 and ends with row size minus 1. This is my row size. Row size minus 1. Your column index starts with 0, ends with column size minus 1. But no, sir. No, sir. I want to tell you something else. This all are student adjacent memory. That means, is it possible for me to write right now? I can erase it. Okay, just I need this. I need the figure. If you have, please write it on your notebook. Don't just only watch. Okay. Can I say in this place A of 0, 7? Can I write it? Think. Can I write this? Yeah, yes or no? 0, 0th row. But 7th column is not there. Oh, you can write it. Why? A of 0, 7 will be interpreted as what? Star of A plus 0 plus 7. A is how much it is what? 215 plus 0 is 215. Star is how much it is what? 115. 115 plus 7 is how much? 115 plus 7 means you have to add what? 28 bytes you need to add. If you add 28 bytes, 115 plus 28 is what? It will be 143. Why you are able to write? Simple reason, all are stored in an adjacent memory. So can I write like this? A of 1, 7. Yes, you can write. You'll access this. Why? A of 1 is this 131. 131 plus 7 is what? It add what? 28 bytes will come here. 159. But so then can I write here A of 2, 7? No. Why no? From here I can't add 28 bytes. It's not possible. Therefore you need to be careful in that. Okay, you need to be what? Careful in that. Yeah. I hope that you understand. Okay. Yeah. If you have any questions, just put it on the comments and I will solve your doubt there. Okay. I'm not letting go. If you have anything, you can ask. Okay, sir. Now in this case, I want to access all the elements. How to do? I want to access what? All the elements. Let us say I want to access all the elements. All the blocks of the matrix. I want to access all the blocks of the matrix. If you remember, we spoke in an array. If you want to access all the elements of the matrix, you must have, what we said, we must have a for loop, right? Now, sorry, all the elements of an array, we need to have a for loop. Okay. Here, what we are going to do, look at. I want to access all of them. Let's see, I wanted to access what? 1, 2, 3, 4. You want to access 1, 2, 3, 4, what I should do? Print %d / t. A of 0, 0 will give me what? Tell me what is A of 0, 0 will give me? 1. Correct? If I say a of 0, 1, what will give me? 2. If I say a of 0, 2, what will give me? 3. If I say a of 0, 3, what will give me? 4. That means in this place, if you want to access 1, 2, 3, 4, I need to put a loop. Correct? I need to put a loop here. The loop should have first time, it should have a 0, 1, 2, 3. Correct? That's what I'm going to do. I'm going to put a loop here. The loop is I write here in this place j, where my j is going to vary from 0. J is less than what? 4. J plus plus. J is 0. 0 is less than way of 0, 0. J is 1, 0, 1, 0 to 0. Correct? I got. Now, if I want to access, if you want to access 5, 6, 7, what I should do? You want to access 5, 6, 7? Okay. So, what I should need to do here in this place is, I need to put next is I put here in this place 1. Correct? If I put 1, when j is 0, 1, 0 will give me what? 5, 1, 1 will give me what? 6, 1, 2 will give me 7, 1, 3 will give me what? 0. Therefore, here I need to put a variable. That's what I'm going to do. Again, I'm going to put a variable where the variable is going to hold what? 0, 1, 2, 3. I'm going to put here in this place I, where my I is going to vary from for I is 0, I is less than what? 3, I plus plus. And after every row, I want a new line. See, the outer loop deals with a row, inner loop deals with the columns. You remember we spoke about in what? In loops, nested loops we talked about. After every row, I want a new line, printf /n. How it works, when I is 0, 0 is less than 3 condition is true, comes inside. J is 0, 0 is less than 4 condition is true. A of 0, 0 will give me 1. Then J became 1, 1 is less than 4. A of 0, 1 will give me what? 2. J became 2, 2 is less than 4. A of 0, 2 will give me 3. J became 3, 3 is less than 4, 4. J became 4, 4 is less than 4, false will come what? New line. Go for I plus plus. I became how much? What? 1. 1 is less than 3. J is 0, 0 is less than 4. A of 1, 0 will give me what? A of 1, 0 will give me 5. Next J became 1. A of 1, 1 will give me what? 6 and 7 and 0. Now J became 4, false. I came out. I went for I plus plus. I became how much? It is what? 2. When I became 2, I is 2 is less than 3. J is 0 again. Then what I said what? 2, 0, 2, 1, 2, 2. I put here 8, 9, 10, 11. Got it? I finished. J became 5, came out. J became 4, I came out. I became 4, came out. That's it. Sorry, I became 3 and I came out. Got it? Yeah. So remember, if you want to access all the elements of the matrix, you must have a nested loop where outer loop will deal with the row, inner loop will deal with the column. Inner loop will deal with the column. Okay? Got it? Yeah. Now let us see what are the do's and don'ts in a matrix are. Okay? Do's and don'ts. Now, sir, I can say integer a of 3, 4. You create only blocks. Okay, so this is valid, right? Now, can I say like this? Integer. Any matrix can be of any data type, huh? Not necessary integer. Okay. Can I say? If you want to say, it has to be initialized at the line of declaration. If you want to say, it has to be initialized at the line of declaration. This is the line of declaration. You have to initialize. I write 1, 2, 3 and 4, 5. In this case, what it does, it creates 2 rows. Each row will have a 3 column. That means the fourth block will be filled with what? Zeros. Therefore, if you are initializing a matrix at the line of declaration, the row is optional, but the column is compulsory because the pointer has to be set. It has compulsory. The row is optional. In this case, it will count the number of rows and put it first. That means it is not possible. It is not possible for me to declare. You can't declare in C, not possible because you need to specify how many bytes you want. Next, can I say like this then? Can I say integer A is a matrix, B is in another matrix of 2 rows and 4 columns? Can I say B is equal to A? Why? Because B is a constant pointer and pointer to constant both. You can't change it. You can't assign. Can I say B of 0, 0 is equal to A of 0, 0. In this case, 1 will be copied in this. Next rule is whenever you are declaring a matrix, your matrix can be of type double, doesn't matter. I can double 4. But your size cannot be what? It cannot be a variable, no variable. You can't have a fractional values. I can't say 3.5, size of 3.5. No. Okay. You can put either a constant here or you can put a literal constant. How to say that you can put a literal constant or a symbolic constant. What is symbolic constant? We in an array we learned using a hash define. I can write here row is 3 and column is 4. I can this is a symbolic constant or a constant variable. I can say like this constant integer r is equal to 3. Okay, the size has to be what? A integer constant. The constant can be either literal or what? Symbolic. Okay, remember. Next, the subscript. This is a subscript. This is what a sorry. This is a subscript. The subscript has to be an integer, irrespective of the data type of the matrix. The subscript has to be what? And okay, keep this in mind. Okay, yeah. So these are the preconditions you need to understand before we work on what? Matrix.